Just let me know. All right, so what's the last thing we have? Properties? Right, metals, non-metals? Okay, which one conducts heat? Metals. Which one conducts electricity? Metals. Which one's shiny? Which one's malleable? Which one's ductile? Metals. Okay, so they have all the properties, basically. Well, I didn't write anything yet. I don't want it to I don't necessarily want it to see me. It needs to see this. So let's just wait until I start writing. Non-metals don't have any of those properties. They don't conduct. They're softer, or they're gases. They're brittle. They're dull. Right? You have all this written down. Okay. When I put sodium in water, Tristan, what did it do? Not potassium, sodium. Reacted. It kind of bounced around and fizzed, right? It's supposed to catch on fire, but it didn't. I put potassium in, what happened? Right. So, assuming the sodium also caught on fire, it didn't work for us, but sodium and potassium both caught on fire in water. Would you say that's a similar reaction?
Yeah.
Yes. Oh, you know what? I forgot to go over the homework. I just remembered that because the last question is talking about that. We'll come back to the homework. So, potassium and sodium had similar reactions. Why?
They're in the same group.
Yes, they're in the same group. Let's write that down. Elements in the same group have similar properties. Now, the properties can be physical and chemical. Physical is kind of like what it looks like, maybe. And then chemical is how it reacts. So I'm just going to leave it at that. Similar properties. And the reason, question mark here, why, you guys are going to tell me. Why do elements in the same group have similar properties? I've been going on and on and on about this. What do I have you look up almost every day?
Because the electron configuration.
Good, because the electron configuration is similar. Be more specific.
It ends in the same number.
Ends in the same number. Very good. Why? Because they have the same number. What do you call that last number of electrons? Valence electrons. Because they have the same number of valence electrons. That's why they react in a similar way. Hey.
Hey, you doing bonding yet?
We're not doing bonding yet, but I'm prepping them. We don't do bonding for a while, but I'm teaching more this year about this than ever before.
Properties.
Yeah, so.
You better remember bonding. Can anybody tell us right now? What are the three kinds of bonds we talked about last year?
Who's got it?
Oh, yeah.
What is it?
Raquel. She said covalent.
Covalent?
I was going to say that.
Ionic.
Ionic?
Yay!
And what?
Hydrogen. Hydrogen.
Okay, hydrogen bonds. Good, good. He was mouthing them as well. All right, good job. Yes, and now there's other ones we'll learn about as well. But those are the main ones.
Guys, happy fun with your electrons.
I will. All right. So that's kind of the last notes we're going to be taking on like the whole periodic table. Now I want to focus on specific elements. Just real quick. Group 1. What's special about them?
They react.
Most reactive metals. Who's the most reactive non-metals? 17, right? Group 17. All right. I put all that. I did all that for that, I guess. But that was 1 second long. All right. So now I want to talk about specific elements on the periodic table. We're going to talk about carbon first. All right. So there's certain elements I want to get into, some details. I'm gonna do that. All right. Yeah, we're good. We're good. We're doing well here. All right. So carbon. Where do we find carbon? List some things that you can find where, what substances or what things contain carbon. Air, more like carbon as it's in the elemental state, not so carbon dioxide has carbon, but I want more just carbon atoms. Graphite. Okay. What else? Diamonds. Alright, so we're going to do notes a little differently than I was planning, but that's fine. And there's one more where's the biggest source of carbon in this room? Who just said what? Someone just said something. No. What'd you say?
Wasn't right.
What'd you say?
Us.
It is right.
Oh.
There's a lot of carbon inside us, okay? Counting the carbon and carbon dioxide. So yeah, all living things, put that down here. All living things contain carbon. I'll be very surprised if you get the third type of pure carbon. Graphite is pure carbon, diamonds are pure carbon. Now, some kids want to say coal. Coal, diamond, basically the same thing, sort of. Coal turns into diamonds eventually. So we could write coal. This molecule or structure is found in soot. And it starts with a B. And it looks like a soccer ball. I'd be surprised if anyone's heard this. D, you with me?
Yeah.
It's called buckyball. That's the third type of carbon. It's called buckyball. Buckminster fullerene. Buckminster fullerene. That's the name. Those are the three types of pure carbon. Graphite, what's that? Pencils. Diamond, you know what that is? And then buckyball, it's just like soot. Okay, so if you had like soot on your hands, or I guess if you have like a bonfire, you burn a bunch of wood, some of the leftover ash and some, I don't think it's actually in ash, but soot is the best way I can explain it because that's where they originally found it. These three here, so I'm a little bit out of order, but that's okay, are called allotropes. Is this on the thing? Help me out. Yeah? Okay. Allotropes. Carbon has 3 allotropes. What is an allotrope? Here's the definition of an allotrope. Different physical arrangement. Am I still on the screen? Different physical arrangement of atoms, but same elements. That's probably the easiest, most straightforward way I can think of it. You would think I would just have a definition in my notes and write that every year, but I tend to kind of do things out of my head, so this changes, which is okay, keeps it fresh. Different physical arrangement of atoms, but same elements. So let's say, let's say each one of you is a carbon atom, and the way you're arranged makes you look like graphite. How could you change how you are arranged so that maybe the class looks different to me? So right now you look a certain way because you're sitting where you are. How could you change your arrangement so it looks different to me? Get into groups. What else could we do? Spread out. What else could we do?
Switch seats.
Right, switch seats with each other. That's kind of all you could do, right? Get closer together, get further apart, or switch seats. Would you agree? Not much else you can do? That's exactly what's going on here. The way that graphite atoms are arranged, the way diamond atoms are arranged, and buckyball are very different from each other. Graphite looks like a honeycomb smushed into thin sheets that are layered on top of each other. Okay, layer after layer after layer. All right, kind of like cake or whatever you can think of that's layered. Diamonds. Diamonds harder to kind of imagine. I have pictures or images online. I don't really have time today. I'll show you tomorrow, or not tomorrow, Monday. But diamond, if you can imagine a building being built, like a skyscraper, without walls or windows, what do they use first to put it together? Steel, I-beams, okay? So if you could kind of picture what that looks like, that's sort of what diamond looks like, very rigid, three-dimensional structure. Buckyball looks like a soccer ball. So that's what an allotrope is. It's if you take the atoms, they're all carbon, just arrange them differently. So if you have sheets of carbon, what color is graphite? Grayish black, right? And it's kind of slippery, you can write with it. So if the atoms are arranged in sheets, that's what happens. If you take those atoms and make them very rigid in a geometric pattern, it becomes clear, very hard, looks like a diamond. So, and if they look like little soccer balls, it looks like soot to you. So it's kind of cool how just how it's arranged will change how it looks and how it behaves. Is graphite hard? No. Diamond's real hard. Okay? So that's kind of an important thing to understand. Hopefully you followed me there. Bell's gonna ring, so I'm gonna stop. You got like 1 minute. No homework except get ready for that quiz. Okay? Groups 1, 2, 13 through 18. I will show the sodium and chlorine video on Monday. I will be here for lab tomorrow, so I'll see some of you in lab tomorrow. Probably. I usually have to go over and edit it. I have to edit this anyway because I got multiple